Alright, so earlier I said that I had the most pretentious sounding title, and I think I've won. I've bested myself with not just rationalizing denominators of radical expressions, but doing it using conjugates. So denominators, remember that's the bottom part of the fraction. Radical means anything in our square root sign, or any kind of a root sign. And rationalizing it means basically being polite. We talked about it earlier, that it's very impolite to bring this to a party. In math, we never put a square root on the bottom. It's just bad manners. And so the new thing we're adding is using conjugates. Wow, this place is noisy. Okay. Is using conjugates, and I'll tell you what those are here in a second. So conjugates is something like this. So let's holy jamalama. Remember what happens when I do this? Why I do that like that? Something like this, and then multiply it by that. Okay, so in simple terms, I could go ahead and FOIL it first. Outer, inner, last. And remember what happens is these cancel out. And that goes anytime we match that pattern. Right? Like that. Now if I first, outer, inner, and last, again, I end up with those two terms in the middle canceling out, and I end up with a squared in the front and a squared at the end. Okay, so we're actually going to use this skill to solve radical expressions in the denominators, or to rationalize denominators of radical expressions. Okay, but note what we have here is we have, if I have x plus 3 times x minus 3, that's going to be basically the first term squared minus the last term squared. Right? X squared minus 3 squared. This one is the first term squared minus the second term squared. Okay. Make sense? Okay, so where this is going to be important is now let's say instead of having x plus 3, x minus 3, let's say I have x plus the square root of 3 times x minus the square root of 3. Okay? So based on what we know, if I multiply these together, I'm going to get the first one squared minus the second one squared. Now this particular trick we're looking at is only going to work for square roots. Okay, so we're not going to do this on any cube roots, it's just on square roots. But the first one squared minus the second one squared. So x squared minus square root of 3 squared is 3. So now look, all of a sudden I don't have any more root thingies in my answer. And this is really awesome. So if I had x plus, say, the square root of 5y times x minus the square root of 5y, then I'm going to end up with the first term squared minus the second term squared. X squared minus 5y. Okay. Let's look at one more example. What if it was a little different? What if I had x times 5 square root of y times x minus 5 square root of y? Okay, so again, we've got the first term squared minus the second term squared. X squared minus, it's going to be 25, right? 5 squared times square root of y squared. Okay? So really that's, I hate to say that's all there is to it, but we're going to use this to get rid of complex conjugate, or to get rid of square roots on the bottom. So basically, if you have something that's a plus a root, you multiply it by a minus a root. Okay? So let's look at some examples. Say I have something like 3 over 2 plus the square root of x. Right? Now I happen to know that it's bad manners to bring a square root of x into the bottom of a denominator when you're going to a, I don't know, math party. So what I want to do is I want to multiply the top and the bottom by 2 minus the square root of x. I don't know why I put parentheses right particularly. Okay, so let's deal with the bottom first. I know the bottom is going to be the first term squared minus the second term squared. Now I'm going to go ahead and rewrite the top out just so it's more obvious of what's going on. Okay, because I want to look at that and I want to say, okay, I want to make sure I distribute that 3 properly. This is kind of the coup d'etat, pièce de résistance. I don't know what it is. It's the culmination of a whole lot of skills that you hopefully develop by now in order to get to the point where you can do this comfortably. And then 4 minus x. All right. Remember, you can't do anything with these 4s and these 2s. Remember, if you can't factor it out, you can't cross it out. I can't factor a 2 out of the top. I can't factor a 2 out of the bottom. So I just leave that as a final solution. It's not any different, really, if I'd had a minus sign, except that whenever I did my multiplication, rather than multiplying by 2 minus the square root of x, I multiply by 2 plus the square root of x. Okay, so I've got 3 times 2 plus the square root of x divided by the first one squared minus the second one squared. So 6 plus 6 3 root x all over 4 minus x. Something like that. Okay? So let me give you a couple of these to play with. Alrighty, so here's a bunch of problems to solve. You know, on something like this, you know, don't let that freak you out. It's just the same thing, except on the top you have to use the FOIL method instead of just a straight distribution. So go ahead and try these problems, pause the video, go work through them, see if you can get them. Okay? So let's try to solve them. So in this case, I've got 3 plus the square root of 2. I want to multiply it by its conjugate. 3 minus the square root of 2. Okay, so I know on the top I'll have this, and on the bottom I'll have the first term squared minus the second term squared. So let's see if I distribute that across. Ka-chonk, ka-chonk. 15 minus 5 square root of 2, and then I've got 9 minus 2. So 15 minus 5 root 2 over 7. And that's as pretty as that one gets. Okay. For this one, let's multiply by 2 minus the square root of 5. So I've got 3x times 2 minus root 5. And I've got the first one squared minus the second one squared. So 6x minus 3x squared of 5. On the bottom I've got 4 minus 5. So this is a little weird, I guess. So I've got a negative 1 on the bottom. So I can think about this a couple of ways. It might be the most straightforward, I'm not really sure. So I can think about multiplying the top and the bottom times the negative 1. Or I can just switch the direction. So however works for you, great. We'll have a positive 1 on the bottom. Distribute that negative 1 across. Minus 6x plus 3x root 5. This is kind of a weird one. And I can reorder that if I want to. Minus 6x. So that one's kind of tricky. If you got to here independently, great. If you actually got all the way down to here, even better. But on a problem like this, you know, this is something you're just going to have to see a couple of times before you remember how to handle it. Okay. Now, if you were kind of stuck on some of the other ones, go ahead and try them again. You know, if you've had some more practice now, pause the video, go try to rework them again. You know, try to see if you can get them to work out. So let's multiply by the conjugate. Okay. So I'm like listening to these people order coffee. It sounds really complicated. I got a hot chocolate. The first term squared minus the second term squared. Okay, so distributing that 2 across, 6 root 6 x plus 8. And on the bottom, 9x minus 16. You know what? That's as pretty as that gets. I can factor a 2 out of the top, but I can't factor a 2 out of the bottom. So I just kind of got to leave that problem as it is. Next one. Multiply the top and the bottom by the conjugate. So I'm going to go ahead and rewrite this. Got the square root of 6 plus 2 times the square root of 5 plus the square root of 3. It's going to be the first term squared minus the second term squared. So I've got first square root of 30, outer square root of 18, inner 2 square root of 5, and last 2 square root of 3. On the bottom I've got 5 minus 3. Okay. Now the square root of 30, let's see, can I do anything with that? I got a 15 and a 2, that doesn't factor. 2 and a 3, that doesn't factor. No, I'm stuck with that. That's as pretty as she gets. What about the 18? For 18 I can go as 9 times 2, so 3 square root of 2. So I can make that a little bit prettier. This is as beautiful as she comes. And same here. It's all divided by a -2. And I can't cancel out these. Try that again. I can't cancel out these 2's. Right? Because I can't cancel out those 2's because if I can't factor it out of the top, I can't cross it out. I can't pull a 2 out of here and I can't pull a 2 out of here. So I'm just kind of stuck with that 2 as it is. Let's try this one. So multiply by the conjugate. 5 root of x minus root of y. 5 root of x minus root of y. So I've got 2 square root of x. That's going to be multiplied by this. Alright, and it's the first one squared minus the second one squared. So I'll take this whole thing and distribute it across. Alright, so I've got 10 times the square root of x squared minus 2 root xy. So that's 25x minus y. And that'll finally come out to 10x minus 2xy over 25x minus y. Okay. Now, you know, some things you want to look out for. It's always possible that you'll end up, like, pretend I was doing all this and I got an answer like, say, 3 plus 6 square root of x over 12 or something like that. If you get a problem like that, remember, if you can factor it out, you can cross it out. 12. So you could take that now and come up with something like this. So I had hoped to have accidentally gotten an example like that, and apparently I didn't. But just be on the lookout for opportunities to go ahead and reduce a couple of fractions when you can. But it's not going to happen as often as you would want it to. Okay, but just remember in general, if you can factor it out, you can cross it out. So look for opportunities to factor things out of the top that will cancel out with things that you have on the bottom.